Andaya. Miss Aileen is executive chemist, evaluates laboratory capabilities and methods, and leads the development of laboratories in South Africa. She has a Bachelor of Science degree in chemical engineering. Prior to joining TrueSoup, she worked as a laboratory supervisor at Siemens Water Technologies Global R&D Center for 6 years. So, on that note, I will hand over the presentation to Aileen, who will start with the introduction to the topic. Over to you.
Thank you, Minal. Good afternoon and good morning to some of you. Today, I will be discussing about the environmental parameters requirements for ISO 30500. But before I proceed, let me give you an overview of the previous webinars we had. For our webinar 1, my colleagues, May and Chris, gave an overview of ISO 30500 and its requirements. And for webinar 2, my colleague, Dr. Rajni, talked about the human health parameters requirements. If you have missed the opportunity to watch these webinars or want to see it again, we have good news as we have recorded them. For those interested, please send a request via our email address and we will send you the link for the access. And to start with our webinar for today, what is wastewater effluent? And what is the importance of monitoring it in any kind of wastewater treatment? Wastewater effluent is the final product or liquid output from treatment processes that meet certain quality standards, which can be discharged into bodies of water such as wetlands, rivers, or streams. The treatment of effluent is vital before it is discharged or used for other applications. In any wastewater treatment, effluent is monitored to ensure that it meets the thresholds as required by different national agencies to, to prevent and harmful effects or damages to human health and the environment. Thresholds for effluent are set depending on what will be its usage or where will it be discharged. For non-sewerage sanitation system, effluent is defined as the treated liquid discharged from the back end or the treatment unit of the system. Oh, sorry, I forgot. So, what are the parameters and their thresholds that needs to be tested for a non-sewerage sanitation system? The environmental parameters of ISO 30500 requirements are pH, chemical oxygen demand, total suspended solids, total nitrogen, and total phosphorus. pH threshold is between 6 to 9. For total nitrogen and total phosphorus, the thresholds are 70% and 80% load reduction, respectively.
Aileen, I'm
Total
really
nitrogen.
sorry to interrupt you here. I think there's a chat window of participant just open at your end, which is giving a gray patch on the screen. Can you please minimize it? It's on the left bottom corner, right bottom corner.
Sorry, it's nothing in my. Everything is closed.
Yeah, it's
Is it
gone.
okay now?
Yes, perfect. Thank you.
Okay, sorry. So okay, to repeat is, so the environmental parameters of ISO 30500 requirements are pH, chemical oxygen demand, total suspended solids, total nitrogen, and total phosphorus. pH threshold is between 6 to 9. For total nitrogen and total phosphorus, the thresholds are 70% and 80% load reduction respectively. The total nitrogen and total phosphorus as required in ISO 30500 shall be reported as percent load reduction. Initial and final concentration shall be measured and percent load reduction is computed. For both COD and TSS, effluent is categorized as Category A and Category B. Category A refers to unrestricted urban uses that comprise all uses where public access is not restricted. Examples are landscape irrigation and toilet flushing, while Category B refers to discharge into surface water and other restricted urban uses that comprise all uses where public access is controlled or restricted by physical or institutional barriers. Examples are fences and temporal access restriction. The threshold for COD are less than or equal to 50 ppm for category A and less than or equal to 150 ppm for category B. For TSS, category A is less than or equal to 10 ppm and category B is less than or equal to 30 ppm. Percent load reduction for total nitrogen or total phosphorus is computed by dividing the difference of the initial and final concentration to the initial concentration and multiply by 100. Why is percent reduction for total nitrogen and total phosphorus are used instead of a specific threshold value? Conventional sewage treatment plants discharge large volumes of treated water because of the dilution of waste by flash water. As a result, they are generally characterized and regulated by their effluent concentrations, and those effluent concentrations are generally low. While on-site treatment or the NSS systems are typically characterized by the lack of dilution water or much smaller flows. Also, flows and dilution can vary greatly between technologies. Thus, the same thresholds of concentration used for sewage treatment plants cannot be applied. In some cases, they would require 99.99% removal, which could be unreasonable and would be unnecessarily high. Therefore, the concept of load reduction was selected instead of a threshold concentration. What are the rationale for the five parameters? pH, COD, TSS, total nitrogen, and total phosphorus are considered necessary in standard environmental performance parameters. pH is a measure of how acidic or basic water is. pH range goes from 0 to 14, where less than 7 represent acidic, while higher than 7 is basic or alkaline. pH 7 at 25 degrees C is considered neutral. If pH is too high or too low, the aquatic organisms living within it will die. pH can also affect the solubility and toxicity of chemicals and heavy metals in water. Chemical oxygen demand, or COD, is a measurement of the oxygen required to oxidize soluble and particulate organic matter in water. COD is an important water quality parameter because it provides an index to assess the effect of discharged wastewater will have on the receiving environment. When COD concentration is high, there is a greater amount of oxidizable organic matter in the sample, which will reduce dissolved oxygen levels. When dissolved oxygen is reduced, it can lead to anaerobic conditions, which is harmful to aquatic life. TSS, or total suspended solids, is a measurement of the total solids in water or wastewater sample that are retained on a filter paper by filtration. If TSS is not removed properly, high concentration can lower the water quality in the receiving environment. The suspended solids absorb light, causing increase in water temperature and decreased oxygen, which creates an unfavorable environment for aquatic life. Total nitrogen and total phosphorus are both considered as nutrients. However, excessive amount can lead to pollution in surface water that can cause eutrophication. Eutrophication is when a body of water becomes overly enriched with minerals and nutrients, which induce excessive growth of algae, which may result in oxygen depletion of the water body. So, why is BOD test not included? Although BOD is one of the commonly used methods for identifying the amount of organic matter in wastewater, it was deliberated by the committee members. But due to impracticality, because it will take a longer time to analyze, which is for 5 days, it was decided that COD is sufficient and that the theoretical ratio of 5 BOD is to 1 COD can be used instead. Here are some photos of the adverse effects when parameter concentrations are not within their thresholds. As you can see in the first photo, there are dead fishes floating in the river. It can be due to sudden change of the water conditions due to contaminations. While in the second photo, it is an example of eutrophication, which is the algae blooms. So when does the environmental parameters are tested? As a requirement of ISO 30500, for the performance testing of NSSS, pH, COD, total suspended solid, total nitrogen, and total phosphorus are to be tested in both controlled laboratory testing and field verification of performance. For Class 1, Class 2, and Class 3 systems that can be installed in a laboratory shall be subject to controlled testing in a laboratory. Tests shall be conducted with actual human feces and urine. Where specified, laboratory temperature shall be between 15 degrees Celsius and 30 degrees Celsius. The humidity and atmospheric pressure in the laboratory shall be reported in accordance with good laboratory practices. The duration of the testing period shall be no less than 32 days and may be extended if more time is required to accommodate back-end processes. It is stated in Table 3 of ISO 30500 the loading pattern and suggested schedule for the different testing procedure. During the controlled laboratory testing, the environmental parameters are to be tested in day 4, 16, and 23 with normal pattern, which means the system is loaded according to its specified treatment capacity with all additional system input specified by the manufacturer. For day 6, diarrhea pattern is loaded, and for day 31, the system is loaded with stress pattern, which means the treatment capacity plus 80% of the difference between maximum capacity and treatment capacity. What is the rationale for testing the environmental parameters in day 4, 6, 16, 23, and 31? Table 3 of the ISO 30500 provides a logical sequence for the different step tests to be conducted. Some of the more important tests are upfront, so that if early failure was observed, one would not run through the entire sequence first. It also made sense to group the tests by nature. Also included in the test sequence are non-usage of this NSS in day 8 to 10, short-term shutdown in day 12 to 14, and long-term shutdown in day 19 to 21. Non-usage is when there is no intentional shutdown of the system by the user and that the system is not used nor has any human interaction for a minimum period of 60 hours. A short-term shutdown is an intentional shutdown of the NSS for 60 hours or less, and a long-term shutdown is more than 60 hours. These non-usage and shutdowns are included in the test sequence to ensure that the NSS is operable and shall be able to immediately accept input and be capable to return to normal operating state without causing malfunctions or requiring additional efforts and time to resume operation as specified by the manufacturer. Under the controlled laboratory testing, the environmental requirements for effluent shall be met, achieving all the thresholds in at least 4 out of 5 test events, with no more than 20% variance from the threshold for any failed parameter. Results shall not be averaged. Meanwhile, for the field testing, the duration of testing depends on the classification of the NSS. For Class 1, which is non-biological system, the testing duration shall be minimum of 30 days. Environmental parameters shall be tested weekly. For Class 2 and Class 3, that incorporate biological treatment process, The testing duration shall be minimum of 5 months, and environmental parameters shall also be tested weekly. In order to pass field testing, at least 70% of all test results for environmental parameters shall satisfy the requirements defined. Results shall not also be average. For the sampling type of NSS effluent, as stated in Table A.2 of ISO 30500, pH shall be collected by grab sampling, and the four other parameters COD, TSS, TN, and TP shall be collected within 12 hours composite sampling. Grab sample is a sample that is collected at one location and one point in time and is representative of the wastewater conditions at the time of sampling collection. Grab samples are preferred for reviewing parameters that change quickly with time, such as pH and temperature. While composite samples are samples that are collected over time based on either by flow or time basis. The samples are composited to present the average concentration of the effluent, designate of the effluent. The frequency for all parameters is at least one sample for designated day of sampling. For controlled laboratory testing, one sample should be collected each in day 4, 6, 16, 23, and 31. And for the field testing, one sample should be collected for each week. So how should be the samples analyzed? As for the parameters test methods, to ensure representative and accurate results, the procedures for analysis of effluent shall follow internationally accepted and recognized test methods. Listed in the table are the recommended test method in ISO 30500. Now, let me discuss the sampling and preservation of samples. For the containers, clean plastic or glass bottles can be used, but you should take note for TSS that a resistant bottle is preferred to ensure that solids do not stick to the bottle. And for total phosphorus, the bottle should be cleaned with 1:1 HCl and washed with DI water to ensure no phosphorus contamination from detergents. For the sample size, normally, the laboratory will indicate the required sample size for each parameters. And for the shelf life and preservations, as pH quickly change with time, it should be measured immediately, and preservation is not possible. TSS can be refrigerated and must be analyzed within 24 hours. And for COD, total nitrogen and total phosphorus, it is still best to analyze it as soon as possible for best results. But if situation does not permit, it can be kept for 28 days, adjusting the pH to less than or equal to 2 and refrigerating it between 2 to 6 degrees Celsius. For the transportations, samples should be kept in an ice box, maintaining at 4 degrees Celsius, using wet ice packs, blue ice, or similar products to maintain temperature. What are the basic safety precautions in handling the NSS samples? Personnel who are involved in the NSS testing are exposed at the high risk to illness from waterborne diseases. For the safety of all personnel involved in the NSS testing and analysis, to reduce the risk and protect the personnel from illness such as diarrhea, safety precautions should be in place. Personnel involved in the NSS testing and analysis should have proper training with regards to proper handling and disposal of wastewater, basic personal hygiene practices, and proper use and disposal of PPE. Some of the basic personal hygiene practices are: immediately remove gloves after NSS testing. Wash hands with soap and water after removal of gloves, before eating, and before and after use of toilet. Do not eat with soiled work clothing and near the NSS area. And change to clean clothing and footwear before leaving worksite. It is also recommended for the personnel to have vaccines like tetanus, polio, typhoid fever, hepatitis A and B, or depending to local health authorities' requirements. The recommended PPE are goggles and face masks, or any splash-proof face shield to be able to protect your whole face from any splashes. Waterproof gloves and rubber boots to protect direct contact or exposure. And liquid repellent coveralls to prevent floating contaminations. As I end my webinar for today, me and my team would like to invite you to watch out for our fourth and final webinar, Introduction to Testing Procedures and Best Practices in ISO 30500. Tentative date will be on the 14th of July and more information to come once the date is finalized. And with that, I would like to thank each one of you who took time to attend this webinar. I hope that you find it informative. If you have other inquiries, please contact us via our email address. Back to you, Minal, for the Q&A.
Thank you for such an insightful session. We will now begin with our Q&A. Your first question is, why total organic carbon is not a part of environmental parameters, as it is a very common parameter to be tested in sludges or wastewater?
Okay, thank you for that question, Minal. Yes, TOC is commonly tested. Its possible incorporation was discussed by the committee, and it was decided that COD was enough and more appropriate.
Okay, moving to the next question. How do you do composite sampling?
Okay, that's an interesting question. So for ISO 30500 requirement is a 12 hours composite sampling. So you have to collect individual samples within specified time interval or flow volume depending on the discharge of the system and combine these samples in one container. Draw required volume from the combined samples to represent the composite sample.
Thank you, Aileen, for answering that. Then moving to the next question. All discharge limits are consolidated as category B. How about if the country has more division of the requirement under this category? Should the standard be followed or country regulations to be followed?
Okay, ISO 30500 is a voluntary standard. A non-sewerage sanitation system will pass the performance testing if they comply with the required thresholds of the standard. But if effluent will be discharged in any category, the country's regulation shall still be followed.
Thank you, Eileen. Your next question is, why are environmental parameters tested for liquid outputs only? What about the solid outputs?
Okay, for environmental parameters, I think it was only considered for the solid output, for the liquid output, because for it was only required for the human health parameters to make sure that there is no other pathogens, and because most of the RT system they don't have much volume, what they call this amount of solid output. Maybe we can also get back to you with regards to the complete answer for this one, because right now or my colleagues can help with that one.
Thank you, Elaine. Moving to the next question. Can we also test COD followed by APHA 5220D?
Okay, so aside from the recommended methods, yes, you can use that APAH 5200D because it's still under the APH and it's considered as a internationally accepted standard methods.
Thank you, Elaine. Your next question is, the value suggested for pH is for reuse purposes. What is the recommendation for discharge when reuse is not intended?
Okay, for pH 6 to 9, Normally, it's the typical range of pH for wastewater monitoring. So it is ideal for either reuse or discharge.
Thank you, Eileen. Your next question is, how many laboratory personnel need to be on site for all environmental testing?
Okay, for that topic, I think sampling team needs to be determined by the laboratory. But with only five parameters, 1 to 2 personnel are more than enough.
Thank you, Eileen. Here's your next question. Are there any significant differences between lab testing and field testing of environmental parameters?
Okay, that's an interesting question. With regards to environmental parameters, there is no significant difference between controlled lab testing and field testing. Performance requirements for controlled lab testing is 80%, while for field testing, it is only 75%. So there's not much difference between the two.
Thank you, Eileen. Moving to the next question. What is the effluent of the NSSS are going to be used in the both categories, category A and category B?
If effluent will be used for both category A and B, the lower thresholds shall be followed to comply for both categories. In this case, category A should be followed as it has lower thresholds.
Okay, thank you, Eileen. Your next question is, can we use on-site instruments to analyze?
Okay, I think yes. On-site instruments can be used, but only if it complies with the equipment requirements of standard methods.
Thank you, Eileen. The next question is, what if the NSSS system cannot be installed in a laboratory?
Okay, if the laboratory doesn't permit the space, controlled laboratory testing may be modified to account for alternative testing environment if the system cannot be installed in a laboratory.
Thank you, Eileen. This is the last question for the day. Why grab sampling for pH and composite sampling for the other four parameters?
Thank you, Minal. That's a good question. Because composite sampling is required for COD, TSS, total nitrogen, and total phosphorus, because it's to ensure that it is a representative of the average wastewater characteristics during the compositing period. But pH is done by grab sampling because it is unstable and change quickly with time. So it is recommended to test pH immediately. Doing composite sampling with pH will not give us an accurate results.
All right. Thank you, Eileen, for your time. If you have any more questions, please write to us at your respective country's inquiry ID. We will answer them for you. You can also write to us on the same email ID if you want to request for webinars about our offerings. I'm sure this webinar was interesting and relevant for all of you. Please do visit our website where you will get the news and updates on our services. Thank you once again for your time and have a good day.